The recording is now started. Okay, so you all have the Zoom link you all got here. So you all can get onto Blackboard, right? You go to the Blackboard website, you sign in, and then when you sign in, there's a list of classes on your left side. One of those links is the link to this class, right? And then you sign in. Is there anyone here who doesn't know how to do that? Who's brave enough to speak up, right? So you have to know how to at least sign into this class webpage from Blackboard, right? Okay, so so you know that, and you're here. So every class is going to be recorded, and so I'm recording it now. I'll go into that. Okay, so let me say a whole lot of stuff first, and then maybe ask questions after, because I'm going to say a lot of things and random topics, and your question might just be answered from the things I'm about to say. Okay, so you're now on Blackboard. Here we are, and so there's a whole menu bar to the left here. So the bottom part is just for me. So so like up to here, this is your stuff, right? So let's go through it one at a time. If you click syllabus, right, that'll bring you to this page, and here's the syllabus. Okay, and so you click that, and you'll save it onto your computer, and then you can view it. Okay, so if you double click the syllabus, so if you double click this button for syllabus, then you'll have the syllabus. Okay, so here's the syllabus. It's on the site, and you can click it that way. My name is Michael Pendazis. Nice to meet you. Classes are Tuesdays and Thursdays from 6:30 p.m. to 7:45 p.m. Okay. So today is the first day of class because Wednesday was the first day of the semester, and so Thursday was first, not Tuesday. Okay, office hours are, and starting next week, it's Tuesday and Thursday. Okay. Office hours are every Friday from 1 p.m. to 2 p.m. on Blackboard Collaborate Ultra. So I will explain what that means in a bit, but just that's when it happens. It's on Friday, every Friday from 1 p.m. to 2 p.m., excluding a few weeks where the college is closed on a Friday. And so I moved the office hour to another day in the same week so that you could still have office hour even though the college is closed on that Friday. Okay. My email for this course is my full name, Michael Pendazis, MICHAEL PANDAZIS FALL 2021 @gmail.com. Okay, this is the email address I'll be using the entire semester for this course. Please send all of your emails to that email address. Okay, so especially when you do an exam, you're going to need to email me your answers afterwards. Excuse me. And so when you email me your answers after the end of the exam, you'll be emailing them to that email address. Okay, not to any other email address, that one. Okay, so it's very important. If you have questions throughout the semester, you can email me at that email address also, then I will answer your emails. Okay. Calculator, it says TI-84 plus at best. Okay, so what that means is that when there's an exam, you are allowed to use a calculator. But if you're using a calculator in the TI series, then I want you to use a calculator at best, a TI-84 plus. Okay, so you can use a TI-84, you can use a TI-84 plus, you can't use a TI-85, right? You can't use a TI-85. That's what I mean. Okay. If you're using a calculator that's not a TI calculator, or a calculator where it has some weird name in it, students have shown me a TI-84 something or other where it's not plus and something else. Just tell me that, and then I'll look at your calculator somehow, and you'll show me it on the video at some point, and I'll tell you whether or not it's good or not. Okay. So that'll be when I'm giving an exam. What I need to see is you in the video. I'm not going to require that your calculator is on the screen, if that's your question. So you asked me, does the camera have to show our calculator? So I think you meant during the exam, do I have to see your calculator? What I need to see is you. Okay, so the entire exam, I need to see you in it. But I understand that question has to do with the calculator. So I'm going to be saying a lot of things. Okay, so in textbook, it's not required for this course. The textbook is a first course in probability and statistics, revised second edition by Peggy Tang Strait. So they discontinued the book. They stopped printing it. You might be able to find it, or you might not. It doesn't matter because I made the whole course so that the book is not required. So this not required in parentheses means that everything you need the book for, I provide online or in a lesson. So you don't need to buy any textbook for this course. But I figured I would list it there. If somehow, if you try really hard and you can find the book and you want to pay money to get it, you can, and it might help. But I don't think there'll be much or any difference because the problems in the book I provide, the lessons cover the material in the book. There's a table that the book uses. I typed up the table and I put it online. So everything that you need from the book is online already. Okay, so you don't need to pay for a textbook. The topics I'm covering in the course, there are 7 topics, and correspondingly, there's 7 chapters. So topic 1 is chapter 1, topic 2 is chapter 2, topic 3 is chapter 3, and you see the pattern. Now, the first topic is on probability. The second topic is combinatorial methods, and so forth. So you see next to the chapter is the name of the chapter, which gives you an idea of what the material is, right, in that topic. Next to each of those is in parentheses is the test number, okay? This is something students often forget or don't understand or realize, right? So a lot of times students ask me, what's on the next test? I'm telling you right here, right? So test 1, it's chapters 1 to 3. See that? So test 1, the material for test 1 is chapters 1, 2, and 3, okay? And those are the topics: probability, combinatorial methods, and conditional probability and independence, okay? Those are all, that's all the material on test 1, okay? Tests are not cumulative, except for the final. So there are 2 tests during the semester and 1 final. Test 2 is on topics 4 through 7. So it's on chapters 4, 5, 6, and 7. Next to, see the test number 2 there, that tells you that these 4 topics are the topics covered in test 2. So the exams are not cumulative. So that means that when you're taking test 2, it's on topics 4 through 7, not on topics 1 through 3. But the material later in the course does depend on understanding of earlier topics. So it's possible that in answering a question from chapter 5, topic 5, you do need to know things from the earlier chapters. So even though there's not a specific question from an earlier chapter, you might need to use the tools in those early chapters in order to answer a more sophisticated, a harder question in a later chapter. That makes sense? Okay, so the material is not cumulative, but it does depend on earlier material. Okay. The course requirements is Math 143 or Math 152. Okay, and that's because you need to know differential and integral calculus. Okay, so especially later in the course, we use integrals and we use derivatives to calculate probabilities and to have discussions about probability. So if you don't know how to find derivatives, if you don't know how to calculate integrals, then you will not know how to solve problems. So I will talk about briefly how to calculate some integrals, how to find some derivatives, but I want to assume as much as possible that you know at least some of these things, right? Especially for integral calculus, there's times where you need to take an indefinite integral, right? And so you have to take integrals that involve infinity in the limits of integration, right? And so it's not just some of them are not just definite integrals. You will also have to compute indefinite integrals. And so you need to know how to do that. Okay, the course objectives. So the goal of this course is to have students become more comfortable with mathematical proofs and get a sense of how abstraction of ideas leads to unexpected outcomes. Okay, so the college told me to write something like that in the syllabus. It's basically a normal math course where there's proofs, right? There's statements, there's theorems and proofs, and I ask you math problems and you have to get the answer, right? Or prove this, or what is the answer to this problem, right? It's a normal math course, but it's a fancy way of saying this is a normal math course. Okay, so course information. Okay, so the course is entirely online due to the coronavirus. Lessons will be on Zoom on days our class meets at 6:30 p.m. Okay, tests will be done in Zoom meetings during class time. And so I go into great detail on how exams are proctored on Zoom in the test folder on Blackboard. So I will talk about that too. There's a place on Blackboard where I give you the information for exams. And so we'll talk about that. Okay, so you're responsible for attending every class on Zoom and taking every exam. Okay, what that means is that I'm not going to be taking attendance the entire semester, right? So your grade is not based on your attendance, right? But the exams are based on what we do in class, right? So you are responsible for all the material that I cover in every class, okay? So if you don't come to class and you don't understand things that was covered, right, you can get problems wrong on the exam. So indirectly, attendance matters, okay? So you are responsible for attending every class. So that way you respond in. So basically that means you're responsible for learning everything we cover in class, and you have to take every exam. You're responsible for taking every exam, okay? So I don't, sometimes students say, I have to go to work that day or things like that. That those cannot be reasons to not take an exam. If you're sick, I understand that, right? If you're sick, I completely understand, especially during a pandemic. If you're sick, I understand that you can't take an exam, and I'm not even asking you to, right? I just mean that there are certain reasons students give where that really shouldn't be a reason for a makeup. Okay, so there's a difference between having a reason to get a makeup exam and not. But in any case, you can always talk to me about it. Don't wait till last minute to tell me there's a problem with taking an exam. Okay, if you know a week or two ahead of time that there's a problem, tell me about it, right? If you're not feeling well a few days before the exam, tell me about it. Maybe you don't feel well starting on the day of the exam. That is even okay, right? Because you weren't not feeling well before, but you have to tell me about it, right? After the exam, you can't tell me you weren't feeling well, right? After the exam is over, you can say, I was sick or I am sick now. You have to tell me before or like maybe during, but that's making my job harder. But not after. Okay. So in addition, you should be spending at least 3 additional hours studying each week, right? So each class is an hour and 15 minutes. So there's 2 of them a week. So you multiply that by 2, that's 2.5 hours. And I just threw in an extra half hour because, studying another half hour won't hurt, right? So I think if you study at least 3 additional hours each week, that's enough, okay? So you have other classes, you have other things to do. Your whole life can't be this class or shouldn't, right? But I think if you budget at least 3 hours, additional hours a week outside of class time for this class, I think you're good, right? In order to do homework, study, and all of that. Before an exam, you probably want to study more than that. Okay, tests. There are 2 tests during the semester and the cumulative final. You will receive a review sheet with practice problems for each test to help you study, okay? And actually, they're already on Blackboard, so you already have them, but I'll show you that. So you must let me know you are sick and cannot take the exam either before the exam starts or during the exam. But during the exam is really kind of close. I'd really rather before, and hopefully not right before. Okay. You cannot let me know after the exam that you're sick. Okay. If we are communicating by email about your exam, you have to respond to emails I send you quickly to be excused. Okay, so if we're having an email conversation about a makeup exam or something else important, you need to respond quickly. That way I can help you, in time, right? Okay, the makeup will be when you're feeling better. So if you're not feeling well, you're sick. I don't want to wait a long time for the makeup exam because it's not fair to other students. But at the same time, I will not push you to take the makeup exam right away if you're sick, if you're really sick, right? I'm okay with waiting under those circumstances to give you a makeup exam, but I don't want to wait longer than I have to. Okay, as soon as you're feeling better and you're ready, I want the makeup exam as soon as possible, as soon as you're feeling better. Okay, there's no extra credit. Okay, so if you do badly in an exam, something like that, I always give the same advice. You have to do better on a future exam. Okay, that's that. So to improve your grade, you have to score higher on future exams. Okay, so the exams will be on Zoom. So the question the student posed was how to receive the exams. So the exams will be during class. It'll be on Zoom. I'll post the test on the screen. So I'll do a screen share. You'll see the test on the screen. You'll be in front of your camera at all times. The camera will be on. Your audio will be off, but you need to have audio that works. And so you'll take the test that you see on the screen while in this meeting. And then after it's over, you email me your answers in email. Okay. I'm going to go over that more too. Okay. So there's no extra credit. Okay. So it's just the tests themselves. Homework. Okay. So I will assign homework problems, and it's your responsibility to do them and ask questions about them when we go over them during class, or to come to office hour and ask questions about them there. So I assign homework problems. I'm not collecting your homework answers. I still want you to do the homework. I'll go over homework at the start of classes. And then if you want additional help with the homework, I'll have office hours and you can ask me questions about them there also. So you'll see the whole test at once. So when I put the test on the screen, I make the test. I try to make the test so everything's big enough so you can read. It's typed, so you don't have to worry about my handwriting. It's typed. It's all on one page, and it's hopefully big enough for everyone to read. Before I start the exam, I put the test on the screen and I ask everyone, is there a problem? Is there something you can't see? Okay, so okay, so don't ask me if there's more to the exam. Everything in the test is in that one page. Okay, but I'll go over this again. Okay, grading policy. So there's two tests, like I said. They're 30% each. It's during the semester, and there's a cumulative final at the end. Okay, so the two tests are 30% each. That's 60%, and the other 40% is the cumulative final. Okay, so your entire test is based off of 3 exams. From my experience, that actually helps students have better grades. When I tried basing off of homework or attendance, both of those things decreased the class grade because students didn't come to class, didn't do homework. Basically, the way your grades end up being best are based solely on exams. Okay, this is CUNY policy on various things, and you can read that, and that's there. Okay, so that's the syllabus. Okay, so let's go back to Blackboard. That's the first link. Course materials. This is a table on values of a probability function. So these are about probabilities of things. This is a table that we're going to use later in the course. This is not in the beginning, and so we'll be using that later. You don't need that now. Okay. Lesson notes. So what I have here are lesson notes. So at the end of every class, I will post the things we did in the lesson in these folders. So today we're doing lesson 1, and right now it's blank because we haven't done the lesson yet. And then next to lesson 1, next lessons, I'll usually put the date. So today I'll probably put 8/26/2021 next to it, right? And so in the future, this list will grow. And so if you come to lesson notes, you'll see folders of past lessons. It'll have the lesson number, it'll have the date that lesson happened. You click on the folder and then it'll give you stuff that we did that day. It'll give you a Word file with the things I typed during the lesson, the notes. It'll give you whiteboard notes if I drew pictures, and it will. I can't post the videos on Blackboard for the entire semester. Eventually, the site doesn't let me, so I'm going to just start posting videos on YouTube from the beginning. So when you click lesson 1 notes, when you click the lesson notes, you'll have the notes and the whiteboard notes, pretty much, and maybe something else. But if you want to watch the videos, you'll have to go to my YouTube channel. Okay, so my YouTube channel is my name, Michael Pendazis. It's a channel. You go there. I made a playlist for this course. So it's fall 2021, Math 241. Okay, so it's Math 241, fall 2021. Okay, so if you go to that playlist, the videos of past lessons will be on there. Okay. Yeah, all my recorded classes will be on YouTube. There'll be ones that already happened, right? So there's nothing there at the moment. So the group chat will have to do with discussions, maybe. People don't really use it, but it's there. Tests. Okay, so the next folder is tests. So there's a whole bunch of things here. So these are the rules for the exam and what to do to take online exams. So there's set rules and set things I want you to do to take exams. I'll go over that in a minute, I want to point out these folders first. So test 1 folder is the resources you can use for test 1. So this is a file with practice questions for test 1. And then this is the answers to those questions. Okay. Don't look at the answers before you do the questions. Okay. And you may want to wait to do the practice questions until you know the material, enough material for test 1. Okay. So there's practice questions and the answers and the next. They're 2 separate files. So you can do the questions without seeing the answers. Okay. Now, if you go to test again, you go to test 2. And then these are the practice questions for test 2 in one Word file, and the other Word file, the answers to those. So the same deal. You can do the questions without seeing the answers. And then for the final, I have even more stuff. I have review problems for the final. I have the answers to those review problems. Okay. I have additional review problems. I don't have the answers to these typed up because there's a lot of problems. That would be a lot of work. Okay, so students wanted more review problems than normal for the final. They said, can we have more? So I made another file with a whole lot more problems. Okay, so for the final, I just had more. You don't have to do all these problems. If you feel you really want to prepare, you can do the ones in those. Okay, I would say at least study the review problems in the first folder. In the first file, which the answers are right below it, I would say at least do that. And then if you want to be really prepared, you have additional problems to also study from. Okay. I've taught this course before, so I gave a review lesson on Zoom for the final for that course. And so if you want to watch a review video before the review, I posted the video of that review. Okay. And see, so this was lesson 23 over the summer, where it was a review. It's okay, so you can watch that video. It let me post that video, so I was able to post that one video, so that's good. Okay. And then these are the whiteboard notes from that one lesson for that class. Okay, so these are the whiteboard notes I used in that video lesson. Okay, so you have all these resources to help you study for the 2 exams and final, and so you have them right now already. So okay, I announced exams up about 2 weeks before the exam. Okay, so you'll know with 2 weeks advance notice when an exam is going to happen. But even before those 2 weeks, you can start studying whenever you want using these things. Okay, whenever you want to. But I would suggest not studying for a later exam. Don't start studying for test 2 when test 1 hasn't happened yet. Okay. There's 2 more files here. It says rules for exam is the first one. So let's talk about that. So rules for exam. Do you see it on the screen? No, maybe not. Let me put this. Okay, so these are the rules. Okay, so 1, the exam will be on Zoom and you're expected to arrive on Zoom at the start of class days. Use the scheduled class link to attend the exam. Okay, and so there's a lot of rules here. Okay, you can go through it, read it. Okay, so my homework, I guess, for the first day for the next class will be to read this Word file. Okay, so I want you to read this file for the rules for the exam. Oops. Okay. I have a million things here on the screen. Okay, so then that's the rules for an exam. So please read that. Next is what to do to take online exams. It's another file. So let's look at that. Okay, so then these are another additional things that go over the things I want you to do to be ready, right? So the first thing is download Zoom onto whatever device you'll be using to take the exam. The device that you will use will need good audio, good video, and a video camera. You will also need a reliable internet connection. Okay, things like that. So for homework for next class, I also want you to read this file. Okay, so read those 2 files for homework, these 2. Okay, so you just go to tests, and these 2 are the links. I guess also I want you to go to syllabus. I want you to read the syllabus. Okay, so these 3 things I want you to read: the syllabus and these 2 files here. That's the homework for day 1. Okay, homework. If you click on the homework link, these are all the homework assignments for the semester. This is not the homework for the first day. So during the semester, we'll have 11 homework assignments. And so when I assign a homework, I'll say, homework 1. I'm assigning homework 1. It's due on this day. And so you'll just go to homework, and then you'll click on the corresponding link here. So if you click on homework 1, that will bring up homework 1. Okay, and so homework 1 looks like this. All right. So this is homework 1. Okay, and so these are problems in homework 1. There's 5 of them. These are problems from the book I typed up and I made as a PDF. Okay, so then, so when I assign homework 1, you'll be expected to do these problems. Okay, and then we'll go over them. Once it's due, we'll go over them at the start of that class. Okay, I'm not grading the homework, right? So I'm assigning them. It's your responsibility to do them. I go over and answer any questions you want at the start of class after it's due. And during office hour, I'll answer any of your questions about any homework assignment. Okay. Okay, so there's these 11 homeworks. The last homework assignment, homework 11, I typed up the solutions to it. Okay. That's because when it's near the end of the semester, there's less time, and also because it's harder. So I figured if I type it up and explain it in a file, that would help you for that assignment. Okay, so the answers to homework 11 are all typed up in that file. Okay, that way homework 11 is explained fully. Okay, discussions. Someone asked me about whether or not there's a place to chat. You can chat here if you want. I've never seen students use this thing, but except for one semester, there was a few questions. So I labeled this description as, if you have any questions, you can post them here, right? You can always email me and I'll answer your questions, but you can also post the question here. If you want to talk to each other on here, I could maybe set up another discussion. So let me know if you want that. Next link is professor contact info. And so that's here it is, that's my name. And there's my same email address from the syllabus. Okay, and so if you forget what my email address is, you can always just go to professor contact info on Blackboard, and there's the email. Okay, I'll remind you what my email address is during exams. Okay, but at any point you can get my email address from professor contact info. Oh, you can't see. Can you see now? It's on the syllabus. You can't see if you click professor contact info. You don't. Oh, wait. I see. Wait. Now you can. Okay, now you can. If you click professor, now I fixed it. If you click professor contact info, you can now see. Oh, okay. So Caesar, I fixed it. Now you can. I don't think anything else is hidden. I'm quickly just checking to make sure nothing else is hidden. Okay, that was the only thing. For some reason, Blackboard made that initially invisible. Okay. Okay, so I think I answered all your questions. Yeah, so I think I've answered all those questions. Now, if you click Blackboard Collaborate Ultra, this link down here, these are where the office hours happen. Okay, so I posted all the office hours for the semester on here. Okay, so office hours are every Friday from 1 to 2 p.m. Right? There are a few weeks where the college is closed on that Friday, and so I moved it. So, for instance, next week, September 3rd, the college is closed, and it's a Friday, which means that we can't have an office hour on that day. So now that office hour for that week is rescheduled to September 2nd from 4 p.m. to 5 p.m. Okay, so it's the day before, and it's before the class starts. Okay, so I thought that would be a good time to reschedule it. Then after that, it's every Friday again, and it continues every Friday. Keeps going every Friday until here. So 11:23. So So November 23rd, right? So after on November 26th, the college is closed. It's a Friday. So I have for that week a Zoom meeting office hour set up for November 23rd, again from 4 to 5 p.m. Okay. So whenever I rescheduled the time, I did it at the same time. But this one's a Tuesday. That's because the college, I think, is also closed on Thursday, if I'm remembering right. Okay. So those 2 days had to be rescheduled. I think that's it. Okay. So if you ever want to make sure there's an office hour for that week, or when is the office hour, you can just click Blackboard Collaborate Ultra, and you can see when the next Zoom meeting is. You can also see when all future you can see the next office hour is in all future office hours. Okay. So this answers your question as to when an office hour is happening. Okay. This is all. Okay. So you have a student starter guide here. This is to help teach you things about how to use Blackboard. You have Queens College Library Resources. You can click on that. Tools and help. Okay, so so that is Blackboard for you. And so okay, so I don't see any more questions in the chat. Or anyone have any questions so far? Okay, good. Okay, so here we are. So that's Blackboard, and you'll be using that during this semester for the course. I also have to take attendance. Okay, so what attendance means for this class is just attendance rosters are due where I have to tell the college who attended class at least once. So the attendance I'm taking is only to say you've attended class at least once. So once I've gotten your attendance for today, I won't need your attendance again for the entire semester. Okay, so okay, so here's what I'm going to do is this. I'm going to okay, so what I'm going to do is I'm just going to call out your name, and then I just want the person, if that person is here, I want them to say out loud here. I'd rather you can type in don't type, say out loud. So turn on your audio, say here, and then turn off the audio. Okay, so let's start. So Jeffrey.
Here.
Thank you. Okay. Eldon.
Here.
Thank you. Edgar Chang. Edgar Chang. Xiang Chen.
Yeah.
Did you say here?
Yeah. Yeah.
Okay. Xiang Chang, you're here. Good. Brian Chang.
Here.
Okay, thank you. Isabella. Isabella. Okay. Cecilia.
Here.
Thank you. Pratiti Das. Pratiti. Okay. Jagmandeep. Sorry in advance when I mispronounce people's names. Jagmandeep. Okay. Lindsay. Lindsay.
Here.
Lindsay, you're here?
Yes.
Wait, is your screen name different than Lindsay? So I see Cheryl, but then that's boxed, but then I hear Lindsay speaking. Let me. Lindsay, is your screen name Lindsay, or you have a different screen name?
She wrote in chat that's her middle name.
In chat? Oh, okay. Oh, so Cheryl's your first name?
Cheryl, yes.
Oh, okay. Blackboard didn't. Okay, Blackboard doesn't have it that way. Okay, so let me type that in for you. Okay, so Cheryl. Okay, thank you. Okay, so that's your first name. All right, let me. Okay, thank you. Kashfi. Kashfi Fahim. Daniel. Daniel Hakun. Thomas.
Yeah.
Thomas, you're here?
Keep going. Can you hear me?
Yeah, okay, good. I just have to confirm,
Oh, okay.
make sure I'm getting it right. So Thomas is here. Jez Rhythm. Kaur, Kaur. Jez Rhythm. Okay, I don't know how to pronounce that. Okay, sorry. Simon.
Here.
Hey, here.
Yeah,
Zin Lu.
Here.
Okay, good. We're getting into a streak here. Alejandro.
Here.
Good. It's 3 in a row. Yana Freddy. F. Martinez.
Here.
Thank you. That's 4 in a row. Farzana. Farzana.
Can you hear me?
Yep, there you are. Okay, good. Okay. That's 5 in a row. Anna.
Hi, I'm here.
Hello. Thank you for having your video on.
Yeah, I felt so sad that nobody turned on the camera. I was like, okay, I gotta turn it on.
Yeah, you have the cat in the background. That was nice.
Oh, you noticed? Yes. I'm
Yeah.
yeah.
All right. I like cats. And somebody else has a cat as the picture. Simon has a cat, I think, as a picture. Okay, so Marilyn, Nessa?
Yeah, it's Nisa. I'm here.
Nessa, you're here, right? I saw you sign in.
Can you
There you
hear
are.
me?
Yep, I can hear you. Good, thank you. Okay, there's 30 screens at the same time. Alif,
Here.
thank you. Kenneth,
Here.
thank you. Avinash,
Here.
Cesar,
Here.
you're here. Yep, you talked in the chat before. Avisha,
Avi, I'm here. Also in chat, 2 people said they were here. Edgar Chang and Pratiti Das.
okay, well, I'll get to those people. It's just I want to do it out loud. Okay, so Avi, you're here.
Yeah, I'm here. Thank you.
Okay, you're welcome. Okay, I can't see 30 video screens and the chat and type at the same time. Well, maybe, but it was making my life much harder. Sadman, are you here?
Here.
Thank you. Kishan, are you here? Okay, people here are still going to be marked present. I'm going to check the chat. Okay, Anil, are you here?
Here.
Thank you. Haram Ritdeep. Haram Ritdeep. Sinj. Haram Ritdeep Sinj. Anil Sinj, I got you. You're here. You both have the same last name, which is confusing. Elvis. Elvis Solano. Okay. Abdul Wahab.
Here.
Okay. Chengzin Yang.
Here.
Thank you. Okay. New streak. 2 in a row. Chang Li Zhang.
Here.
Okay. Yeah. So you there. Jai Hu Zhang. Jia Hu Zhang. Jia Hu Zhang. I see your name on one of the videos. Are you here? Okay, you're on the chat. Sit here. Okay. Okay. I got a lot of people there. I'm now gonna swing back and look in the chat for a minute. Doing on the chat is making it much more difficult. For TD Das, you're here. You typed in the chat. Okay. All right, this is going to take another 5-10 minutes now for the chat. Okay, so here. Okay, so make sure that your audio and video works. You need it to work for the course. It's one of the requirements for the course. Okay. Edgar Chang, you're here. Okay. Yep, you're here. Okay. Okay. Cesar, I already marked you here. So you're here. Okay. Munir. Yeah, I already got you. What is that? Okay. So I still have a few more names. I looked in the chat. I do not see these people at all on the chat either. I didn't hear them, but I'm going to go through it again. Okay, so if you hear your name now, I want you to say here out loud, or at least in the chat. Ignore a previous message of what you said, though I looked, I didn't see anything from these people. Isabella Cooper, are you here? Isabella Cooper? Isabella? Okay. Jagwandeep Daliwal, are you here? Jagmandeep? Kashfi, are you here? Kashfi Fahim? Kashfi Fahim? Daniel Hakoon, are you here? Daniel Hakoon? Okay, Jesrim Kaur? Jesrhythm? Jesrhythm? Kishan Shah? Kishan Shah, are you here? Kishan Shah? Haram Ritdeep, are you here? Okay, Xiang Cheng, who's sent, I could maybe internet wasn't working. You're already here. You're already marked present. Haran Ritdeep Sin, you here? Elvis Solano, are you here? Elvis? Okay, so I didn't hear from 1, 2, 3, 4, 5, 6, 7, 8. Muhammad Islam. Muhammad Islam. Okay, so that's a good. Okay, so that's good. Okay, so did you just did you just join the class recently?
Yeah, I joined in like last 2 days.
Okay, that's why. Okay, so I have an attendance list I have now. When new people sign into the class, it does get put in Blackboard. There's a delay. And okay, let me go through the names of people who weren't yet on my attendance list when I saw it. Okay, so Mohammed Islam, right? You said you're here? You're here?
Yes.
Okay, that doesn't mean you're not in the class. The attendance list is updated, so that's all. Zach, yeah. Okay, even if I look at the attendance right this minute, it may not be entirely updated because there's a delay. So I don't know everyone that's in the class at this present moment. So you need to speak up. So if you're in the class, you need to tell me you are. So Muhammad Islam is here. I have you here. You're accounted for. Nothing to worry about. Zach Mamdow, you're also here. Anyone else? Anyone else here? Register for the course. Did not get their name in the attendance. Anyone else? Anyone else? So anyone else not hear their name called? Who was present? Other than Muhammad, Islam, and Zach Mamdouh? Those two? Okay, so everyone here heard their name. Okay, so okay, so there's 37, 29. Perfect. I have 29 people here, and there's 29 people in this room. Let me just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 29 names, and one of them is me. So other than me, there's 29 other people. So I have 29 students. Perfect. All right. So I think I have everyone. Okay. So we can move on from the attendance for now. Keep in mind that if, oh, you already have this on the screen. Once I've pulled your attendance, all 29 students have I called attendance, you are now accounted for the entire semester. Okay, so in the future, when I take attendance, I'm only taking attendance from those students who were not counted as present. Okay, so you're good. Okay, so I only need 8 more students. Okay. Good. Okay, so now an hour in, we can get started. So you should see Word on the screen right now. So this is Math 241 Lesson 1 Notes. And so let's start. Okay, so the first chapter of this course is on probability. It's an introduction to probability. Okay, and so section 1.2 of the book is what is probability? Okay, the sections, I'm going to put these numbers here, are going to be corresponding to the sections in the textbook I use for the course. And so it follows a little bit of a strange indexing system. You have to get used to it. So when I do this, I'm referring to the sections from the book. Okay. So the question is, what is probability? And so the answer is that we're going to be talking about 4 definitions of probability. Okay. And so that's because there have been 4 since the 17th century. Okay, so they're referred to as the following. One is called classical probability. Another one is called empirical probability. The third one is called subjective probability. And the fourth one is called axiomatic probability. Right? Right, so I'm saving this file and then it will be uploaded onto Blackboard on the lesson notes folder. So if you don't have time to write everything down, taking notes is good, I suggest it. If you don't have time to write things down, the entire file will be available on Blackboard in the appropriate lesson folder after class. Okay. Okay. So we will talk about each of these 4 briefly in this section. The most important one to mathematicians and in this course is axiomatic probability. Okay, so most of our time will be spent on axiomatic probability. The best one is last on the list. Okay. So let's start with classical probability. Okay. So to illustrate an example, to illustrate classical probability, let's look at this one example. So let's say you roll a balanced 6-sided die. Okay, so you have a balanced 6-sided die. That means it's fair. So when you roll the die, the numbers 1, 2, 3, 4, 5, and 6 are on the die, right? And whichever side is facing upward, the number on that side is the number you roll, right? By it being a balanced six-sided die, that means that all 6 sides are equally likely to appear at the top after you roll it, okay? So there are 6 equally likely outcomes. That's from the fact that it's a balanced 6-sided die. And so those outcomes I'm going to put into a set. And so they're 1, 2, 3, 4, 5, and 6. Okay, so those are the 6 equally likely outcomes of rolling a die. So you can find the probability of an even number being rolled, right? And so what is the probability of an even number being rolled? Anyone want to answer out loud? So if you roll a
1
balanced
out of
6-sided die.
6.
Sorry, what?
1 out of 6.
Who's speaking? So I can.
Oh, that would be me, Jeffrey.
Hi, Jeffrey. So even,
Good
right?
evening.
What numbers are even?
Pardon me, sorry. Oh, 1 out of 2. Pardon me.
1 out of 2. Yeah. Okay, but okay. Well,
Yes.
just answer the side question anyway. You know it. What numbers are even?
2, 4, and 6.
Right. Okay. So how many even numbers are there?
3.
Good. Now, how many total ways could you roll the die?
6 different ways.
Right. So the probability is 3 over 6, which you said is 1/2 equals 1/2, right?
Mhm.
Good. Okay. So right. So that's how you find the probability of an even number being rolled in this example. You know that it's equal to the fraction, the number of number of evens divided by the total number of rolls, possible rolls, right? Total number of evens. So it's the total number of evens divided by the total number of possible rolls. There are 3 evens out of a total of 6 possible rolls, and so that's 1 over 2, right? And so this is a classical probability example. And note that 3 out of the 6 equally likely outcomes are an even number, right? And so we needed the fact that every side of the die is equally likely to be rolled. And we have that assumption from the fact that it's a balanced 6-sided die, right? It's balanced. It's weighted, the weight is even on the die, right? It's possible to have a die that's weighted so that one side is more likely to be rolled than another, right? And so if some sides roll up more often than other sides, then you can't calculate the probability in a simple way. But this problem is structured so that it's a very simple problem. Make sense? Okay, so this is an example of a classical probability problem. Okay, so now that you see an example of it, let's look at this definition. So if the event under consideration was the occurrence of any one of n possible outcomes among the total number, capital N, of all possible outcomes, and the probability of that event was defined as little n divided by capital N. So this is a definition of the probability of an event, okay? In classical probability. So this definition is if the event under consideration was the occurrence of any one of n possible outcomes among the total number capital N of all possible outcomes, then the probability of that event was defined as little n over capital N. So in our example, there are little n equal to 3 little n equals to 3, which is the number of evens. And capital N, which equals 6, is equal to the total number of dice rolls. Okay? And so in this definition, the little n corresponds to the total number of evens, and capital N corresponds with the total number of possible rolls. Okay? An event is a subset of the total of the set of all outcomes. Okay, and so the event of an even number being rolled is the event 2, 4, and 6, right? So the event of an even number being rolled is equal to the set 2, 4, and 6. Okay, and this event has size as a set, little n, which equals 3. Okay. I'm just kind of reiterating the same information a few times. The total number of what they're called simple outcomes is capital N, which equals 6, which is the size of the set 1, 2, 3, 4, 5, and 6. Okay, explaining explaining a above example. Okay, so you can see how this definition in classical probability defines the probability of that event. Okay, so it matches your intuition of a probability, right? Okay. Now, the classical theory can be applied to any chance situation involving a finite number of equally likely outcomes. It excludes many other chance phenomena of interest. Okay, so in our dice rolling example, right, we had a dice rolling where there's 6 outcomes and they're each equally likely to occur. And there are so there's finitely many possibilities and they're each equally likely. And so in that framework, we can use classical probability to calculate probabilities. But not every situation is that simple, right? And so even though classical probability makes complete sense and it's easy and everyone would agree with it, it just doesn't cover every possible situation that can occur or that you'd want to think about. Okay, and so that's the disadvantage of classical probability, that it doesn't cover every possible chance phenomenon. Okay, and so you need more advanced, more sophisticated versions of probability in order to cover more situations. Okay, and so now let's talk about another one. And so for this one, we're going to talk about empirical probability. Okay, so here's a definition. If capital S is an experiment with unpredictable outcomes, and if capital A is one of the possible outcomes of capital S, then we say that the empirical probability of the outcome capital A is the number little p if in repeated performances of experiment capital S, the long run relative frequency ratio of occurrences of capital A tends to the number p. this is a definition of the empirical probability of an outcome A. Okay,
I have a question.
what?
So I came late to like I came like later I came late to class. So do you like took attendance already?
Yes, I did. Okay, I marked you here. You're here.
So so when the notes will be up.
Sorry?
So when is the like the lecture notes will be up by when, today or tomorrow?
Well, I teach in the class after this one. Every time we have class, I teach it right afterwards. So usually you'll probably get everything a little later at night. So I'll try to have everything posted by the end of the night. I might need some time the next day. So not long after though, the class. Yeah.
Okay, thanks.
You're welcome. Okay, so we're talking about empirical probability, right? So here's the definition of empirical probability. Definition: if S is an experiment with unpredictable outcomes, and if A is one of the possible outcomes of S, then we say that the empirical probability of the outcome A is the number P if, in repeated performances of experiment S, the long run relative frequency ratio of occurrences of A tends to the number P. Okay, so what does that mean, right? A, this capital A here, right? It's an outcome, right? An outcome is an event. An outcome is a subset of the set of all outcomes, okay? So note that here, capital A is an outcome. But an outcome is a collection of but an outcome is a subset of the set of all, let's call it simple outcomes of the experiment. Okay, so this definition I'm saying before I explain some terminology. So as an example, rolling an even number when rolling a fair six-sided die is an example of an outcome, okay? So an outcome in that experiment does not have to be rolling a 1 or rolling a 2. An outcome could be a collection of possibilities, okay? So rolling an even number is an outcome, okay? You don't have to just select one possibility. It could be a collection of possibilities, okay? So that's what's meant by an outcome. So this definition is defining the empirical probability of an outcome, meaning you don't just, it's not just telling you the definition of the probability of one thing happening, it's telling you the probability of any collection of things happening. So we can talk about the empirical probability of rolling an even number. We can talk about the empirical probability of rolling a 1. We can talk about the empirical probability of rolling a 2. We can talk about the empirical probability of rolling an odd number. You can say the empirical probability of rolling a 1, 2, or 8, 1, 2, or 6. Make sense? Okay, so that's what is meant by an outcome A. Okay. So P is just a letter denoting the number that we care about, right? The empirical probability of the outcome A is going to be a number. Little p is the variable, is the letter we're letting denote that number, okay? But that number is given to us by the following. It says that if you keep performing an experiment, right? And you actually perform the experiment and you record how often your outcome occurred out of the total number of times you ran the experiment. That ratio will eventually tend to that number P as you perform the experiment infinitely many number of times. So what I mean by that is if you roll a die 6 times, right? And let's say your outcome is rolling a 1. Then if you roll the die 6 times, let's say one of those 6 times you roll a 1, then your relative frequency ratio would be 1/6. you got a 1 once out of the total 6 times you rolled the die. That would be the relative frequency ratio of occurrence of A. Okay, that would be if you perform the experiment of rolling a spare 6-sided die 6 times and you got a 1 once, then your relative frequency ratio for 6 experiments would be 1/6. If you did the experiment 12 times, if you rolled the dice 12 times, you'd be performing the experiment 12 times. And if 2 of those times you rolled a 1, then your relative frequency ratio for 12 repeated experiments of that experiment would be 2/12. Make sense? And then if you perform the experiment 18 times and you got a 1 4 times, your relative frequency ratio would be 4/18. Make sense? So for every number of times you do the experiment, you're thinking of a particular fixed outcome, and you're just recording how many times that outcome occurs. And the relative frequency ratio is the number of times your outcome occurred divided by the total number of times you did the experiment. That's the frequency ratio of occurrences of an outcome A. Okay? What this definition is saying is that we're saying that eventually, if you do this experiment infinitely many times, that fraction you get, the total number of times your outcome occurs divided by the total number of experiments, that fraction will limit towards a particular number. And that number, is defined as the empirical probability of the outcome A. Okay? Okay, so let me rephrase the definition in another way. So that definition means that if little n is the number of occurrences, is the number of repetitions of an experiment capital S, and n sub A is the number of times capital A occurs, and little p is equal to the limit as n approaches infinity of the frequency ratio, which is n sub A over n. And if little p equals that, then the empirical probability of the outcome A is the number p. Okay, so what that definition means is that if little n is the number of repetitions of your experiment S, and n sub A is the number of times that outcome occurred in those little n repetitions of the experiment S, and little p is the limit of n sub A over n, is the limit of those relative frequency ratios, then the empirical probability of A is the number little p. Okay, but there are drawbacks of empirical probability. So class is almost done. I'm going to end it very soon. Drawbacks of empirical probability is you can't repeat an experiment infinitely many times. That's impossible, right? And so what that means is you accept the relative frequency ratio n sub A over n as the empirical probability of an outcome A if little n is a large number. Okay, this would be a scientific approach to probability, because you would perform an experiment and then you'd see a certain number of times where you got the outcome you were looking for. And you would say that if you did the experiment enough times, that ratio would be, you would accept it as being the likelihood of something happening, but you would really hope that it would be close to it. It wouldn't necessarily be the probability. You would realize that, but you'd say, okay, well, I've done it enough times that I think that this is close, at least, to what the actual likelihood is. Okay, and so as a mathematician would not want this, and so that's a major problem with empirical probability, which is why axiomatic probability, which we'll talk about later, is what we will prefer. Okay, and so I'm going to stop here because the lesson ends here. And so next class, we will continue talking about empirical probability. And the other two types of probability. Okay, and cover more material. Okay, and for homework for next class, like I said before, read the syllabus. The rules for an exam, rules for exams, and what to do to take an exam on Blackboard. Okay, so read those 3 things, and I'll see you next class. So I took attendance, and so yeah, so we'll talk more about it. I'll give you an example too. Okay, though actually I already did give an example about the well, if you roll a die, right? If you roll if you roll a die, right? But you actually roll it. You don't just think hypothetically that you rolled it. If you actually roll the die and you actually write down how many times an outcome occurs and divide it by the total number of rolls, by actually rolling the die, you're doing an empirical experiment. Okay. Classical probability would just be thinking of, the odds, right? But empirical would be actually rolling the die and getting a probability from rolling it. Okay, so that would be an example. But we'll talk about that more next class. But that might have answered your question already. Okay. Okay, so I've now recorded the lesson. I'm going to stop recording.